Hey guys, in the previous video lessons we have learned how to make the graphs of parent sine and cosine function. Also we learned the transformation and the transformation parameters and their meanings with respect to the sinusoidal functions. Now we would see how the transformation parameters are going to change the look of your parent function graph. From your previous knowledge, you know that a mapping formula is used to make your transformed parent equation function graph. However, when it comes to sinusoidal functions, we will not be using the mapping formula anymore. Instead, we will be using a different way of making a graph of a transformed sinusoidal function. Let's learn how to do that. In this video, we will deal with graphing of transformed sine function. Let's write the question first. Question is, gx is equal to 5 sine 2x minus 30 plus 4. If we match it to our general transformed sine function equation, we can write our parameters out. So my a is 5, my k is 2, d is 30 degrees, and this is right. C is 4. If I want to turn this equation into a graph, I would first make my axes. This is how my axes would look like. Then I'm going to follow these steps in order to make it into a graph. So the first step is use C to plot the first thing on the axes. In this particular case, because C represents the equation of axes, so we would use C equal to 4 in this example to plot our equation of axes. And let's say we mark 1, 2, 3, and so on, the numbers on the axes. Y equal to 4, we would make our equation of axes. And this is our equation of axes. The next step is to use A and C to determine max and min points. Now to determine max and min points, all you have to do is just do C plus A, and we see C value is 4, A value is 5. Then we add it up, it gives us a 9. Then we do C minus A, which is 4 minus 5. This gives us a minus 1. Always remember, the higher value will represent a max and a lower value will represent a min. So my max is a 9. I'm going to mark my max point, and I'm going to mark my min point, which is a negative 1. So this was step number 2. Next step is step number 3. And in third step, we have to use K to find time period. And we know time period is 360 divided by K. In this case, K is 2. So it will give us the time period to be 180 degrees. So K is the third thing to use. Use of K continues in further steps as well. So step number 4 is divide time period by 4. Always you have to divide time period by 4. In this case, we have a time period as 180 degrees. When we divide it by 4, we get 45 degrees. Step number 5 is to take first 4 multiples of 45 degrees to plot on your x-axis. And this would give us 45 degrees as the first multiple, 90 degree as a second multiple, 135 as a third multiple, and 180 as your fourth multiple. We'll use these 4 numbers to plot on the x-axis. Let's see how it looks on the x-axis. So this is definitely my 0 degree. This is 45 degrees. This is 90 degrees. This is 135 degrees. And this is 180 degrees. We can mark these points on the axis of symmetry as well, just in case we don't do any mistake when we are plotting our graph. So these are the first point is always on the axes. This is our multiples of 45 that are represented on the axis of symmetry. The next step is to use the parent function to determine how the graph would look like. So our parent function is sine. Before that, let's mark these points as A, B, and C because these all come under step 3. And let's mark this as step number 4. So using the parent function is our step. Now let's recall our parent sine function graph. It looks like this. Always remember, any parent function graph will have 5 major points on it. These are the 5 major points that we would see on the parent function graph. So the first is, let's call these points on the equation of axes as midpoints. So this is point number 1, point number 2, point number 3, point number 4, point number 5. So point number 1 is the midpoint. Point number 2 is the max point. Point number 3 is mid again. Point number 4 is min point, and point number 5 is, so when it comes to a sinusoidal function, sine function, we have mid, max, mid, min, mid. This is when the a value is positive. How would the parent function graph change when the a value is negative? Because a is just going to make the graph go reflected over the x-axis. So instead of going up, the graph will then go down. And in that case, the points are going to be, this is first point, second point, third point, fourth point, and fifth point. So first point is mid, second point is min, third point is mid again, fourth is max, fifth is mid. So this is the scenario when a is positive. This is the scenario when a is negative. And this all comes when the graph is a sine graph. If a is negative, we see mid, min, mid, max, and midpoint. Now we go back to our transformed function equation or the question, and we see that this is a sine function with a positive. Since a is positive, we would follow mid, max, mid, min, and mid technique to make the graph. And all we have to do is just connect the dots. When we connect the dots, the graph is going to look like this. So this is how our sine function graph looks like if we do not consider our phase shift. You see, we have not yet taken into account the phase shift, and we already have our graph. With practice, you're going to learn these steps, and this is going to not take more than maybe 2 minutes. Now here, since we see there is a phase shift involved, so phase shift is your step number 5. And we see our phase shift is 30 degrees. So let's write down this under our steps. So my step number 5 is use phase shift to translate the graph left or right. In this particular example, our D is 30 degrees right. So we would use this to translate the graph. Let's see how this looks like. You see, our first point is at 0. Instead of making the first point at 0, we'll now make it 30 degrees right. So if this is 45, this section, if we divide it into 3 parts, this is going to be 15, this is going to be 30. So 30 is the second part every interval. So 0 to 45 interval, second part is 30 degrees. So we are just going to shift this midpoint 30 degrees right. Not only this, we're going to shift the max point also 30 degrees right. So similarly, I have my max point now at this spot. That is going to be somewhat here. Then I have my midpoint again 30 degrees right, which is going to be here. My min point 30 degrees right, which is going to be here. And my midpoint again 30 degrees right, which is going to be here. I'm going to connect these dots to get my final graph, and this dark pink is my final graph. Let's do another sine question for the sake of practice. If my equation is y is equal to sine 2 theta minus 90 degrees, how would I turn this into a graph? First of all, I will make sure that this looks like my general transformed equation. Because I'm missing an a, so I'll put a 1 there. Sine, I know that I have to factor my k out. When I factor 2 out, I'll be able to get theta minus what multiplied by 2 will give me a 90 is 45. And then I don't have any c value, so that's a 0. Now I will quickly do the steps. The first step is to plot equation of axes, and that is y equal to 0. If I have to make my equation of axes at 0, I'm going to make this on the x-axis. Next step is to use a is 1, c is 0, and get the max and the min points. Finding max and min points, I will do c plus a, which is 0 plus 1 equal to 1, and then c minus a, which is 0 minus 1 equal to negative 1. You know what, let's make this a negative so that you can get a hang of negative a as well. So if this a is negative, because of a being negative, my max and min are going to change now. So I have 0 plus minus 1 is a negative 1. 0 minus negative 1 is a positive 1. I told you the higher value represents the max value. So my max is going to be a positive 1. And the lower value represents the min value. My min is negative 1. I'm going to plot my max. Let's say my max is here, and I'm going to plot my min, and my min is here, negative 1. Now, since we have completed step number 1 and step number 2, step number 3 is we'll use k to find out time period, and k is 2. So we would do 360 divided by 2, which is 180 degrees. When we divide 180 degrees into 4 parts, we would get 45 and its multiples. And all we have to do is just put all these multiples on the equation of axes. So 45 is your first point, 90 is your second point, 135 is your third point, and 180 is your fourth. Once we have all these 4 points, we're done this part. And the next part is to look at the parent function. Our parent function is sine function. And also look at how does a look like. A is negative. So we will be following the rule of a negative sine graph. And that is, the first point is the midpoint, next is a min, next is a mid, next is a min again, and next is a max. So we would go make mid, min, mid, max, and mid. We have not yet taken care of the phase shift. So if we do not take care of the phase shift, or if there was no phase shift, this would have been our final answer. But since there is a phase shift, we will shift the whole graph 45 degrees right, and that's our fifth step. So since phase shift is 45 degrees right, we would use that to change our graph. So we'll move every point, midpoint, instead of at 0 will now be at 45. Min point instead of 45 will now be 90. This will move 45 right, this will move 45 degrees right, and this will further move 45 degrees right. So your final graph would look like this. And this is how we make transformed function graphs when the function is a sine function.